Jai Jivendra, Namaste and welcome to my channel. Today we are going to solve the 76th question of the problem solving series and the first question of the topic linked list. The difficulty level for this question is easy and this question has been asked in Microsoft, Amazon, Intuit, Google, Walmart and many other companies. This is a very basic question. Find the middle of the linked list. Okay, so we have already discussed arrays, strings and many other topics. So in linked list, you know how this linked list is defined. Linked list is one of the data structure, very important data structures in computer science, where the order in which the elements are the elements are present is not sequential. Okay, like we can access array from a0 a2, the same array a5 from its index, but here we can't do that. We have to traverse one by one. Say if we want to find the fifth element of the linked list, then we have to traverse one by one to reach fifth element. Okay, so it's not sequential. Even the memory space is also not contiguous in the linked list. You need to study about the linked list. I hope you all know what is linked list. If you don't know, study about the data structure linked list and then only you will understand this question. Okay, so linked list is better used for insertion and deletion. The insertion and deletion operation is very it can be done in linked list in order of 1, but in arrays we can't do it because every position has to be then again shifted, so that takes order of n, but in linked list we can do it in order of 1. Okay, so I hope you please study linked list, the data structure linked list, and then come to the 76th and the playlist and understand different 15 questions of linked list that we are going to solve in the next 15 videos. Okay, so let's start. Find the middle of the linked list. So this is the structure that is given. It has a value. Linked list is a node which has some data stored and then a pointer that points to the next linked list node. Okay, like here. So this is the linked list. So this is the data 1 and this is the next pointer which points to this 2. Okay, then 2 points to 3, 3 points to 4, 4 points to 5. We need to find the middle element of the linked list. Okay, so you know, right, what would be the middle element? There are 5 elements. What would be the middle element? This is the middle element, right? So we need to return this, since it's given list node, the list node as the data type, so we need to return this pointer, not the value, the pointer. Okay, so here in this case, what would be the middle element, right? So here there is 5, so this is the 5 by 2 is 2, right? So 3, 4, 5, 5 by 2 is 2.5, that is 2. So 1, 2, 3, 4, 5. So there are 5 elements. So the middle element would be this third element, right? It's not like 2.5. So it would be this index, the next part of this element, right? So since we are starting with 0, so 0, 1, 2, 3, 4. So the 4th by 2 is 2. So this is the index that is the middle. So here 0, 1, 2, 3, 4, 5. Okay, so 5 by 2 is 2.5. So this will be our middle of the element. Okay, right? So how do we solve this? So one thing you can do is you can find the size of the linked list, right? So when we have an array of 10 elements, say if these were 10 elements, 1, 2, 3, 4, 5. So to point out the new node 0, 1, 2, 3, 4. So the middle element will be 4 by 2, 2. So you just give this 2, right? Half of the element, right? Similarly, if we count this size of the linked list, we'll traverse this linked list, we'll count the size. Say we got the size as n equal to 4. So n equal to 4, that means the linked list number which you want to find is index maybe 4 by 2, that is 2. So then we will traverse the linked list twice and we will get our number. Similarly, we can do for this one as well. What would be the time complexity? We are traversing the linked list twice, one to get the full size and then secondly to get the half of its size. So order of time complexity would be order of 2n, which is order of n, and we have not taken any extra space, so order of 1. So as simple as that, right? Can we optimize this further? Yes, we can. So the optimized solution is single traversal. In single traversal, we can solve this, and space complexity would be order of 1. And this algorithm we will use in many other questions. That's a famous algorithm. tortoise and hare algorithm, right? So let's discuss how we are going to solve this with tortoise and hare algorithm. So we will take two pointers, slow and fast, both pointing to 1, and we will move both the pointers till this becomes null, because after that there is a null pointer, right? When this ends, that means the 5 is pointing to null. So we will move both the pointers, but we will move slow once and fast we will move twice. When we move slow, we will move it one, and then fast we will move twice. So after one traversal, slow would be here, but fast would be here. Okay. In the second traversal, slow will come here and fast will come here. Now fast's next value is null, and fast is not null, but fast next value is null. So fast cannot travel. So when we see that fast cannot travel, we will break the loop and will return the slow pointer. Slow pointer is in 3, so this 3 will come. Got it? Let's code this. List node strict slow equal to head, strict fast is equal to head. Okay, fine. While fast not equal to null and fast next not equal to null. If fast is also null, we can't travel, right? And fast next not equal to null. Slow will not be null. Before slow, fast would be null. In the beginning, fast is and slow are same, pointing to head, right? Not equal to null. What we do? We do slow is equal to slow next, and fast is equal to fast next. Okay, and when this fast will reach null or fast next will reach null, we will return slow, and this slow would be the middle of the linked list. So this is solved in this 3 lines of code. Okay, so here in this case, when slow is here and fast is here, okay, then slow comes here, fast comes here, then slow comes here, fast comes here. Okay, now fast next is not null, and so fast next is not null, and slow's next is also not null, so slow's next will not be null. So this fast will become fast ka next. Since this is not null, so fast next ka next is null. This one is null, but slow will move ahead, and this answer will actually not be 6, it would be 8. Okay. So here in this case we take the base, right? So there are 6 elements, so 6 by 2 is 3. So we take this as our middle. Okay. This complex, so n by 2, if it is we take the middle as n by 2, the ceiling, not the floor, not the ceiling. Okay, so 8 comes as our middle of the linked list. Okay, I think the solution is clear. The link to the question is given in the description. Please try it yourself and then come to my code walkthrough section. Here is the code walkthrough of the 76th question, middle of the linked list in the LeetCode platform. You can see this question has been asked in multiple companies. And let's look at the example. So here 1, 2, 3, 4, 5, the example that we discussed, 3 is the middle element, and here there are 6 elements, 1, 2, 3, 4, 5, 6, and we take this as our middle element. Okay, this is the middle element, the 4th one, not the 3rd, the 4th one. Okay, n by 2, the ceiling. Okay, let's look at the solution. We did the same thing what we have discussed. Okay, and then we submit it. Okay, it has been accepted. Here is given actually, if there are 2 middle nodes, return the second middle node. That's why we are returning this. Okay, this mentioned, this was little ambiguous, 3 or 4, so it's given that we need to return the second middle node. Otherwise we could have made some changes in the code if they would have asked the first middle node. Okay, See you all soon in the next video where I will be explaining the second question of the list and the 77th question of the problem solving series. Jai Jirendra.